Here in this video, we are solving a problem from fluid statics, and the problem is like this. Let me read out the problem for you. When two liquids of equal volumes are mixed, their effective density is 4. Let me stop there and try to explain to you what's the meaning of that. He said there are two liquids that are mixed having equal volume and their density is. We shall know first of all what's the formula for the density is. We know density of a liquid is defined as mass by volume. When two liquids are mixed, I can simply say total mass by total volume. If you observe a little carefully, you have information regarding volume that they are of equal volume, but we don't have any information about their masses. So let me assume if their masses are say rho 1 and rho 2, I can write rho 1 as, basing on the same definition, m1 by v1. And so in the place of m1, I can just take the v1 to that side. I can write rho 1 v1. Similarly, in the place of m2, I can write rho 2 v2. That implies their effective density is, in the place of m1, I can write rho 1 v1. In the place of m2, as I have explained, rho 2 v2. By v1 plus v2 is the general formula. But he has given a specific condition. Say that they are of equal volume. That means v1 equal to v2. Say that is equal to v. That implies rho will become rho 1v this equation and rho 2v by v plus v. So that will become v common, rho 1 plus rho 2, denominator 2v. So the effective density of that case is rho 1 plus rho 2 by 2. That's what given for you. That is equal to 4. So I can simply write 4 is equal to rho 1 plus rho 2 by 2. That implies rho 1 plus rho 2 is 4 into 2 is 8. That's the conclusion that we draw basing on the first part of the problem. And then there's the second part of the problem. Let me solve it in the same way, right? Let's try that. I'll just scroll down. Let me read out the problem before that. When same two liquids of equal masses, understand carefully, earlier it is equal volumes, now equal masses are mixed, their effective density is given for you. So I will solve the same way, but it is about equal masses, not equal volumes. Yeah, let's go to the problem. Again, I will let the same formula, density equal to total mass, because two liquids are mixed, by total volume. In the second part of the problem, there is information about equal masses, but there is no information about the volumes. So what I can write, taking the volume this side, density this side, in the place of V1, I can write M1 by rho 1. Just this term is shifted here. Similarly, in the place of M2, I can write V2, I can write M2 by rho 2. Let us substitute these two values in this equation. Yes, what I will get? Rho as M1 plus M2 by, in the place of V1, M1 by rho 1, and in the place of V2, as I have explained, M2 by rho 2. And it is given that they are of equal masses. So let me assume M1 equal to M2 equal to M. Then rho will become M plus M here. M1, M2 is equal to M. By M by rho 1 and M by rho 2. So if I simplify, M and M is 2M. The denominator, I can take M common. 1 by rho 1 and 1 by rho 2. So this M and M will be cancelled. Rho is equal to 2 by denominator of the denominator. Rho 1, rho 2, rho 1 plus rho 2. That implies 2 rho 1, rho 2 by rho 1 plus rho 2. So now let's go to the problem again. See what the problem is. Yeah. It was being said their effective density is 3 when they are of equal masses. So he's saying this entire value is equal to 3. That implies you can get, yeah, I have written in reverse here, so this is not correct. 2 rho 1 rho 2 will come to the numerator. So rho 1 into rho 2. So 2 rho 1 rho 2 by rho 1 plus rho 2 is given as 3. But we have already found in the previous part of the problem that rho 1 plus rho 2 is 8. I can just substitute the data here. Yes, 2 rho 1 rho 2. Rho 1 plus rho 2, as I have shown, is being already proved as 8, 3. So 2 rho 1 rho 2 equal to 8 into 3, 24. That implies rho 1 rho 2 equal to 12. So here we had two conditions left with. So what are the conditions that were left with? Rho 1 plus rho 2 is 8 basing on the first part of the problem. Basing on the second part of the problem, rho 1 and rho 2 is equal to 12. You can easily solve, or you can even simply guess also, right? So the possibilities of rho 1 and rho 2 to become 8 is somewhere 1, 7, 2, 6, 3, 5 like that. But rho 1 and rho 2 has to be 12. Therefore, the values of that rho 1 and rho 2 has to be 12. And rho 1 and rho 2 together is product is 12 can be found only with two values. What are the values? You can guess, of course. Rho 1 is 2, rho 2 equal to 6. Of course, whatever may be the basic units that were being given for you, gram per cc or so. So these two values, 2 cc and 2 gram per cc and 3 gram per cc, satisfies these two conditions. So you can solve the problem in this way. And while you are solving the problem, hopefully you have learned one core important point. The density, very definition of the density is mass by volume. And you found that when equal volumes are mixed, effective density is rho 1 plus rho 2 by 2. And when equal masses are mixed, their effective density is 2 rho 1 rho 2 by rho 1 plus rho 2. In fact, I have derived these formulas in the previous video too. This here I have derived only for the reference of this problem and to make this problem independent of that derivation. That's it. Thank you for watching.